Bismillahirrahmanirrahim, everyone. Assalamu alaikum. I hope everyone is doing absolutely great. In the last session, we actually saw the development of the strategies and the risk mitigation and risk analysis, where we actually saw that how can we actually identify the risks? How can we, using the different tools, like we actually saw the Porter's five forces, then we actually saw how can we actually do the SWOT analysis to identify the potential strengths and the weaknesses and the potential opportunities in the market, and as well as the threats in the market. We also saw that how can we actually analyze those risks based upon P&I matrix, which is probability and impact matrix, and how can we actually draw that probability and impact matrix by identifying the probability of occurrence of each risk and the potential impact that each risk might have on our business. Now, what we are going to actually cover in this lecture is basically analytical hierarchy process. An analytical hierarchy process is basically used at places where you have to make a complex decision, and it's just not that easy to make a decision, right? Because there are a couple of criterions and there are a couple of alternatives that we decide based upon which we can actually define we can give the different weights on those criterions and those alternatives, and based upon the calculations of the eigenvectors, we can actually decide that what decision we can actually come up with. So let's start this lecture with an analytical hierarchy process. Analytical hierarchy process was founded by Professor Thomas Sati in 1980, which is popular and widely used within the methods of multi-criterion decision making, and which actually allows both qualitative and the quantitative criteria, because we would see that how can we actually, if something is qualitative, how can we actually convert that qualitative into a quantitative perspective, and then through those quantitative criterion and alternatives, we can actually evaluate what possible decision based upon those criterion and those alternatives we have to take, right? This analytical hierarchy process has actually a wide range of applications and can be used categorically on the places where one has to actually take the decisions, complex decisions, where there is no single one decision of an individual. It has to be actually carried out in the group. We actually saw this strategic decision cycle, in which we actually saw where we can actually have this identify the problems, and then we go to the establishment of the decision criteria, then weigh decision criteria, and then generate the alternatives, and based upon these alternatives and evaluation of these alternatives, we choose the best alternatives, and based upon the weights of these alternatives, and then we actually implement the decision and then evaluate the decision later on. So the steps, like identify the problem and these decision criteria, the weighing of decision criteria, generation of alternatives, evaluation and choosing the best alternatives, and based upon these alternatives and the criterion, we actually would see in analytical hierarchy process these steps very thoroughly, that how can we actually weigh the criteria, how to generate the alternatives, and so on and so forth, right? And how to come up with the decision. Now, analytical hierarchy process is basically based upon two steps. The first one is the relative weights of the decision criterion. So in this portion, we can actually see that initially what we have to do is we have to actually develop certain decision criterion. Now, these decision criterions will actually become the base for the larger perspective or the broader perspective of what our decision should be based upon. And then we need to have some alternatives, because we need to actually see that which possible alternatives we can actually choose, because there might be not be only one alternative, there might be actually multiple alternatives alternatives within those decision criteria, which we can actually use. For example, if we want to actually buy a car, we can actually buy what sort of a car do we want to buy, and this is exactly what we're going to solve in this lecture. We're going to see this thing very thoroughly as an example, right? Now, this is basically your decision-making process. First is basically the problem. For example, we have to, just like I said, what kind of a car should a person buy? Then the factors or the criterion is basically your gas mileage, or the roominess, the cost, based upon which you can actually make a decision, right? So generally, these factors or criterion may actually then be used as a pairwise comparison, such as gas versus the storage, and gas versus cost, and storage versus cost, and so on and so forth. And amongst the alternatives, then we have to see that whether, based upon these criterions and based upon the comparison of these criterions, how can we actually compare between the different types of the cars, like SUVs or sports or sedan, right? So if we have to make a comparison amongst, the decision criterion, that would actually, this comparison would also be done based on the alternatives, that whether the gas mileage was the storage for the SUVs, whether the gas mileage and versus the storage for the sports cars, whereas the gas mileage and the versus the storage for the sedan. And same is the case over here with the gas mileage versus the cost, the storage versus the cost amongst these alternatives over here. So when we have a large amount of the criterion, and we have got a large number of the alternatives, it actually becomes very difficult to come up with the decision. So this methodology actually helps in complex decision making, where there are multiple number of the criterions and there are multiple number of the alternatives through which we can actually come up with a certain decision, right? So I hope you can actually you can assess the depth of this analytical hierarchy process, that how can this analytical hierarchy process can help you in decision making, where there are so many things and there are so many alternatives you have, where you can actually choose any one alternative. But that's not the point, that only one alternative has to has a certain method, so that you should not actually suffer because of the wrong decision that you have made. Now, so analytical hierarchy process is a structured technique for dealing with the complex decisions. AHP provides a comprehensive and rational framework for structuring a problem, for representing, quantifying its elements, for relating those elements to overall goals, and for evaluating the alternative solutions. Now, analytical hierarchy process uses, and it can be used anywhere though. But its applications generally are where the selection of one alternative from a given set of alternatives is available. Then prioritization is one of the key essence of this analytical hierarchy process, where you put the alternatives in a certain order, and then you actually see which is the least desirable and which is the most desirable. And these alternatives actually base upon certain criteria. Then for the resource allocations, for example, if you want to allocate some resources, you want to actually see that which of the decisions would actually help you in attaining the maximum progress. You want to actually benchmark yourself with compare yourself with the rest of the processes, where you want to actually do some quality management, where you want to see the quality improvements, and you have to actually see that whether a certain process has actually, or maybe there are multiple processes in line, and all those processes, you can actually see that amongst all those processes, which process will actually give you the maximum, performance or maximum edge. Then this is actually also used for the conflict resolutions, where you can actually resolve the disputes between the entities, where the things are little incompatible amongst the positions. Maybe that those positions could be the management positions, or maybe any other position. Now, coming up with the example of the car selection, our objective in this lecture is to select a car. Uh, we actually define three criterions, which is style, reliability, and fuel economy. And we actually have a certain alternatives, for example, Civic Coupe, Saturn Coupe, or maybe Ford Escort and Mazda Miata. Now, these are the different types of the cars, right? Whereas these are the criterion based upon which these alternatives will actually be assessed. Moving onwards, our top hierarchy, let's actually make a tree. The first thing that we should do is to actually make a tree. Over here, these three over here are basically the criterion. And each criterion should be assessed based upon the alternatives that we have, right? So this is exactly what I said earlier. Now, when we actually make a pairwise comparison, we actually make a comparison based between the grades, ranging from 1 to 9, generally. And wherever we actually make a comparison, if a certain attribute is more important than the other attribute, then we actually weigh it as 9. And if, for example, the other attribute is less important, we equally make it 1 divided by 9. So if our attribute A over here is absolutely more important than the attribute B over here, then it would be A would be actually weighed as 9, and B over here would be actually weighed because it is absolutely less important than A, right? So it would be actually graded as 1 by 9. Is this clear? Right? So based upon this concept, we can actually make our pairwise comparison, where we can actually make a certain matrix, where we can orthogonally make the lower off orthogonal or maybe off diagonal as a certain image of the other diagonal. For example, over here we'll see that just in the coming up slides. With 1 is actually equal importance. 3 is somewhat more important. 5 is much more important, very much more important, absolutely more important, which is 9, right? And 2, 4, 5, 6 is basically intermediate values, which actually would need to have a comparison with each other. And we need to actually compromise when compromise is needed, right? Which actually means that okay, it is not decided, it's just an intermediate, maybe it is important and it is not important, right? So if I'm going to choose 4, which means it is between somewhat more important and much more important, which some would actually say that it is somewhat more important and some would say that it is much. So as I said, this exercise has to be done in the groups. So if some people are saying that it is somewhat important and some people are saying it's much more important, and some people say that we have to weigh it as 3, and the rest of the people are saying that we have to weigh it as 5. So if it is in the middle, so we actually evaluate it as 4 because it is actually a disputed argument. So we can actually come up with 4, which is an intermediate value. Now, so in this slide, we can actually see that based upon this matrix, based upon the decision, which is actually decision, which is actually ranking scale criteria, we can actually now rate. And we are going to do is in the diagonal. What we are going to do is we are going to actually have all the ones over here, right? In the diagonal between this is the criteria that we are looking at right now, which is style, reliability, and fuel economy. So we're going to do it style, reliability, and fuel economy. And over here, we are also going to have style, reliability, and fuel economy. Now, in the diagonal over here, what we can do is we can actually rank it as 1. The diagonal is 1, which is style versus style is 1, and reliability versus reliability is 1, and fuel economy versus fuel economy is 1, right? And now, for the time being, just leave this upper portion for the time being. And what we are going to do is we're going to concentrate on the lower portion over here. This lower portion, if we actually look at this diagonal, this one, right? So now understand this thing because as per the previous slide, if something, as we mentioned over here, that if the attribute A is absolutely more important than B, then rank it 9. And based upon this principle over here, we can actually see that if the reliability is more important than the style, right? And the two is over here is an intermediate, right? So if it is more important than the style, then rank it accordingly. So if I actually say that, okay, fine, it is between equal important and somewhat more important, then I rank it as two. If you think that reliability is very much more important than the style, then you should actually put a 7 over here, because we can actually see in the scale that the scale for very much more important is 7. So we can actually put a 7 over here, right? But for the time being, for this example, we are actually considering 2 over here. Now, again, is fuel economy important than the style? If you think that style is more important than the fuel economy, right? What we have done over here is we have put 1 by 3, because we think that the style is more important than the fuel economy, right? If the fuel economy was more important than the style, we would have actually put 3 over here, or maybe 6, or maybe 5 or 4, but not 1 divided by 3, or 1 divided by 5, or 1 divided by 6, right? If we are putting 1 divided by 3, this means that style over here is more important and fuel economy is not that important, right? But again, over here, this means that the reliability is more important than the fuel economy. And according to the scale over here, it is 1 by 4, which is actually intermediate, right? Over here, it is 1 by 3, which actually means somewhat more important. This means that the style is somewhat more important than the fuel economy, right? Now, once we have actually decided that what we have to actually put over here in the scale, now always begin with this one diagonal, and I'm pretty much sure that you must have understood. If you want to repeat, I'll just repeat it once again. That the reliability is one as more important than the style. That is why we are actually putting 2 over here, not 1 by 2. If reliability was not important as compared to the style, we would have actually divided it by 1 divided, right? So we have written 1 divided. Over here, because the fuel economy is not that important as compared to style. Style is, we are giving more weight to the style as compared to the fuel economy. So that is why it is 3, 1 divided by 3, right? If it was, if let's assume that the fuel economy had more weight as compared to the style, and we actually weighed more to the fuel economy as compared to the style, and for us the fuel economy was more important than the style, we would have actually marked 3 or 5 or 7, whatever value we wanted to actually give it based on our own decision. Now, once we are done with this thing, I told you that forget this particular part, right? Now, what we are going to do is we are going to actually replicate this portion and make an inverse in the upper portion. For example, if it is 2, which is reliability, as compared to the style, which is 2, what we are going to do is we make it 1 divided by 2, because reliability is less important as compared to the style is less important as compared to the reliability. Now, similarly, fuel and style. When we are comparing fuel and style, this fuel economy and the style, was originally 1 by 3. Now we are going to put 3 over. Now, reliability, fuel economy and reliability, it was 1 by 4 over here. We are going to put a 4 over here. So our matrix is complete, which is 1 in the diagonal, and 2, 1 by 3, 1 by 4 over here, and 1 by 2, 3, and 4. So this portion is this particular portion, which is triangle over here, is actually an inverse of this blue portion over here on the upper, right? So I hope this is pretty much clear now. Now let's assume, let's actually put these things in decimals. For example, 1 divided by 3 over here is basically 0.333, and 1 divided by 4 over here is 0.2500, and 1.00, and 0.5, and 3.0.5, because it's 1 by 2 over here, 0.500, and so on and so forth. What we are going to do is we are going to actually divide it and convert it into decimals. Once this is done, what we are going to do is to multiply the matrix. By the multiplication, the people who, I believe you would know that how to multiply the matrix. If you don't know that how to multiply the matrix, I tell you that the row over here multiplied by the column. For example, the first row multiplied the first column, then the first row. Now this multiplication, whereas the first row multiplied by the first column would actually provide you with the first element over here, right? So this is actually 1 multiplied by 1, which is 1 multiplied by 1, which is over here, right? Then it is 0.5 multiplied by 2, which is 0.5 multiplied by 2, plus 3 multiplied by 0.333. Right? So that's, this actually gives you 3. So you'll write the 3 over here. In the next step, your first row and the second column. That would actually give you the second part, which is 1.75. Then the first row again and the third column, right? So you can, with the same principle which has been mentioned over here in this section, right? So you are going to get this 8.00 when you're going to multiply the first row and the third column, right? And the same goes with the second row and all the 3 columns and the third row and all the 3 columns. What you're going to get is basically this matrix, which is 3.00, 1.758, and 5.332, and so on and so forth. This matrix you're going to get after the multiplication of the same matrix, right? Once this is done, we do next is to actually generate the eigenvalues and normalization. What we're going to do is we're going to add, because this is the matrix that we had got, right? So what we can get is this is 3.00 plus 1.75 plus 8.6, right? So we're going to add all these over here, right? All the rows, all the elements of all the rows, but this has to be added like, you know, in the rows, right? Not like the columns. So it is 3.00, 1.758, and we're going to get 12.750. And this over here is the second row and the summation of that, and the third row and the summation of that. And then we are going to add in the next, what we're going to add is all 3 of them will be added to give 39.9165. Once we have received 39.9165, what we're going to do is we're going to divide this one element, the summation of one row, with 39.16. So once we divide this over here, 12.7550 divided by 39.1565, and so on and so forth, which is 22.332 over here divided by 39.9165, and then 4.83333 divided by 39.9165. So the resultant that we get would be 0.3196, 0.5548, and then 0.122. Now, you will reach, you know, the normalization. Basically, right now, what we have actually got is basically this one part is your eigenvector, right? You have received that eigenvector, and when you sum this eigenvector, you actually have, you'll actually get something which is very close to 1, or maybe 1, right? Ideally speaking, you should be getting 1, right? But if your value is 0.967, 965, or 9, something like that, you just assume that there is a little bit of an error, but generally the calculations are all right, and you are actually achieving 1. Right? But if the values are like 0.5, 0.4, something like that, then I believe that is going to actually be a problem for you, right? And it should not actually exceed 1 as well. Like 1, you should not be getting 2, you should not be getting 3, you should not be getting 1.7, not like that, right? So either it should be 1 or it should be 0.97, 96, 95, maybe 92, with a little bit of an error. Yes. So once we have achieved the eigenvector, we are going to actually see that because the style actually has 0.3196, and 0.55. This is our fuel reliability is 0.55084, right? And which is 0.5584 over here. And then our fuel economy is 0.1120, which is over here. So basically, what we can say is that based upon this eigenvector, which is one, which is the car, we actually see that the most important criteria that we are actually looking into is actually reliability, right? So initially we thought that reliability was being overlooked somehow or the other, because we actually saw that the reliability over here was more or less, we were not choosing the but based upon the eigenvector, we can actually see that the most important factor over here is the reliability, then is the style, and then the fuel economy. So the fuel economy is probably the least priority that we have in this, right? The highest priority or the highest importance that we are giving while making a decision is this, the reliability. Now, based on the reliability, now what we need to see is based on the criterion and the weights assigned to the criterion. Now, what we have to decide is that we have to see that which of the alternatives fit us best, right? Again, what we are going to see is that based upon the criterions which we have actually weighed recently in the previous lectures, we are going to actually do the same exercise that we had actually done in our earlier exercise to actually assign the weights accordingly, whereas civic, probably we can say that in the diagonal, it's basically all one, right? And in over here, Saturn is more reliable than the Civic, or we can say that Escort is a Civic is more reliable over here than Escort, and Miata is more reliable than Civic. Miata is again more reliable than, and Miata is again more reliable based upon this is basically the style. The reliability is over here. So if we actually see that, we can say that Saturn is more stylish as compared to the Civic, whereas Civic is not that stylish as compared to the Escort. Whereas Miata is actually more, even more stylish than the Civic as compared to Saturn. Then again, Miata is again more stylish than the Saturn and the more stylish than the Escort. Based upon the reliability, what we are going to do is we are going to actually make the diagonal again and say that Saturn is not as reliable as that of a Civic. Escort again is not as reliable. Miata is, I don't think there is a decision, because over here what we said was equal importance, right? One was the equal importance. So we can actually see that one is equal importance. And then 1/2 is obviously Saturn is more reliable. Then over here, the Saturn is again more reliable, but over here, Miata is more reliable than Escort, right? So what we are going to do is we are going to actually develop the same eigenvectors as we did in our previous slides, just like the calculation by the multiplication and then adding the rows and adding, we can actually come up with the summation and dividing the summation, and we'll have to repeat the process for all of the alternatives again now, right? So for all of the alternatives, once we have done all of the alternatives over here, because this is actually the style and the reliability is basically qualitative variables, they needed to be converted into the quantitative variables. This is the reason why we actually came up with a certain scale to actually provide you with this one matrix. But if there is something which is already quantitative, like for example, fuel economy. Fuel economy is actually already quantitative. So what we can do is we can actually see over here that miles per gallon and then 27 miles per gallon, 24 miles per gallon. We can actually see that all the alternatives over here can be actually assessed based upon the miles per gallon. And once we have done this, we can actually add all of these and divide them by 113. So once we actually divide them by 113, all of these values, we can actually get a normalized value which can actually provide us with a eigenvector, right? So this is how we actually treat with our quantitative data. whereas we can actually treat with the qualitative data by using these matrices, right? But eventually, what we have to do is we have to define the we have to normalize it, and then we have to come up with an eigenvector which actually gives us a value like close to 1 or maybe 1. Now that we have actually done the things for our alternatives as well, and we have actually come up with the eigenvectors, and the eigenvectors over here for all the alternatives are actually given over here, right? So what we can do is we can actually develop a matrix based upon these vectors. Like this, these four elements, and these four. So we're going to have like a matrix like this, where we can actually get the civic and Saturn and Escort and Miata on our this side, and then style, reliability, and fuel economy on the upper side. Right. So this is now our priority matrix. This is where we are going to actually develop our priority and make a priority to see whether we can actually, which car should we actually select. So this is actually a product between the alternatives criterion, which is basically over here, this alternatives, and then we are going to actually have a product with the criterion eigenvector, which we had actually selected before, which is written over here, 0.3196, 0.5584, and 0.1222. So we are going to actually see that based upon, because we had actually weighed reliability as one of the highest criterion, which is the most important criterion. Based upon the other criterions as compared to the reliability, and as compared to and making a comparison amongst between all these alternatives, we're going to actually see, and we're going to actually have a product between the eigenvectors which were generated over here for all these alternatives, and the vector which was actually generated for our criterion. So multiplying both, we actually get 0.30, 0.27, 0.08, 0.35. Now, based upon this result, we can actually see that Miata wins the race, right? So because this is our, this is the highest number that we have. So this highest wins the race. So what we are going to do is we are going to actually buy Miata based upon what we actually decided, and the exercise that we did based upon the criterion that we defined, which was the style, reliability, and fuel economy, and the alternatives that we had in the market, right? So amongst all these alternatives, we actually decided that based upon the reliability, style, and fuel economy, we choose Miata, right? Probably the reliability is it's very much reliable. Maybe it is just also stylish, right? Maybe a little bit of a fuel economy, but it's actually based upon all, right? So this is the result of analytical hierarchy process. So I believe that you must have understood by now that what does an analytical hierarchy process actually mean. So this is a little bit of this is a basic chart, right? So again, it is basically based upon your complex decision making, that what you have to actually do. There are some softwares which actually can calculate some, do this analytical hierarchy process and do the computations on your behalf. This is an exercise that you have to do, right? And this is basically, I hope this is, I have actually solved it down there, right? I'm not going to explain all of it though. It's actually the same process that we'll be choosing. However, what you can actually do is you can actually do this exercise on your own as well. Where Peter is offered 4 jobs: Acme Manufacturing A, Bankers Bank B, Creative Consulting C, and Dynamics Decision Making D. Right? He bases his evaluation on the criteria and such allocation, salary, job content, and long-term prospects. Right? And then the decision upon the relative importance over here. Right? So what you can do is you can actually create your own criterion and your own. Now the criterions are actually given over here, which is location, salary, content, long term, and location. Alternatives are locations. And the alternatives over here. You can actually. Sorry, the criterion is basically A, B, C, D, and the alternatives actually are location, salary, content, and long term. Let me think. Yeah, I think that would do. Yeah, I think these are the alternatives. A, B, C, D are alternatives, and these are the criteria, right? So, location, salary, content, and long term are basically the criterion, and these are basically the alternatives: A, B, C, D. So, I believe you can do your this exercise by yourself. Just imagine yourself. What we can do is we can actually get 4 alternatives based upon these criterion given over here, and where would you like to get a job, right? Or maybe which business are you going to actually start? So based upon that, you can actually do this exercise yourself as well. So for the time being, um, this lecture is over. I hope you must have understood analytical hierarchy process. That's what an analytical hierarchy process is, and you must have understood it completely. If you have any questions, you can actually ask it below in the video comments, or you can actually wait till Thursday. We will be having like always, we will be having a Thursday session by 10 o'clock in the morning, so you can ask questions over there. So till next time, Allah Hafiz and bye bye.